Picture a machine the size of a 12-story skyscraper, laid on its side, buried under a mountain. It can't go forward, can't go backward, and it's supposed to be powering Australia's entire energy transition. That's not a hypothetical. That's what happened. This is the story of TBM Florence and the engineers who had to reinvent the Earth itself to get her back. The backstory first. Australia is building something that sounds almost too elegant. A gravitational battery. An actual gravitational battery. Snowy 2.0 pumps water up to an elevated reservoir when electricity is cheap, then releases it back down through turbines when the grid needs power. 27 kilometers of tunnels through the Australian Alps. Enough stored energy to power 3 million homes for a week. The whole thing stands or falls on the machines that dig those tunnels. And one of those machines went underground and couldn't come back. Before we go underground with Florence, we need to go back, way back, 530 years before the birth of the Roman Empire. The island of Samos, Greece. A small city is dying of thirst. Its only fresh water source is on the wrong side of a limestone mountain. The tyrant Polycrates needs a solution. He hires an engineer, a man named Eupalinos of Megara. And Eupalinos proposes something audacious. Eupalinos is going to dig a tunnel through the mountain, 1,036 meters, through solid limestone. No explosives, no powered machinery, iron picks, fire, and time. But that's not the remarkable part. Eupalinos decides to dig from both ends at once. Two teams, opposite faces of the mountain, boring toward each other in total darkness. No GPS, no radio, no electronic surveying, just geometry and the courage to trust it. Eupalinos walked equal horizontal distances around the mountain slopes, set reference markers, calculated the angles by hand, told both teams exactly where to dig. 2,500 years later, you can still walk through that tunnel. The two teams met within approximately 1 meter of each other, 1 meter of alignment error, across more than a kilometer of solid rock, with iron picks in the dark. That tunnel is still there today. The Eupalinos Tunnel, Samos, a UNESCO World Heritage Site, and a blueprint, literally, for what happens when you run out of options underground. There's another thing ancient miners did that gets almost no attention. When the rock face was too hard to chip, they didn't force it. They built fires against the tunnel wall. Big fires, let the rock heat through, then threw cold water on it. The thermal shock cracked the rock from within. The material itself changed, not because they overpowered it, because they altered its physical state first, then cut through. That technique is at least 2,000 years old. You're about to see engineers use the exact same principle with slightly different equipment. So here's the principle at the heart of this episode. When the Earth refuses to yield, you have two choices. Change the Earth first, then advance, or send the second team from the opposite direction. Eupalinos did both. 2,500 years later, engineers in the Australian Alps would face the same problem, with a machine weighing 2,000 tons and an entire country's energy grid depending on the answer. The snowy mountains are not friendly geology. The rock under Kosciuszko National Park isn't a neat layer cake, it's chaotic. Millions of years of tectonic stress have broken it into shale, siltstone, and fractured sandstone, saturated with groundwater, compressed, folded, unpredictable. And running right through the planned tunnel route, the long plain fault zone, a geological boundary where solid granite can transition without any warning at all into something that behaves more like wet sand. The surveys didn't fully detect it. Florence would find it the hard way. To understand why that matters, you need to understand what a TBM actually is. It's not a drill. It's a self-contained mobile factory. The cutter head at the front spins and fractures the rock through sheer compressive force. Dozens of steel disc cutters, enormous hydraulic pressure. The excavated material, the spoil, gets swallowed and conveyed out the back on a continuous belt. At the same time, in the rear section of the machine, robots position the permanent tunnel lining, concrete segments, 7 tons each, 9 segments per ring. The machine eats forward and builds behind itself simultaneously. Florence was designed to advance 30 to 50 meters per day. Florence herself is extraordinary, named after Florence Violet Mackenzie, Australia's first female electrical engineer, 142 meters long, 11 meters in diameter. If you stood her on her cutter head, she'd be the height of a 12-story building. Over 2,000 tons of steel, hydraulics, and sensors, more than $100 million of machine. Her mission, 15 kilometers of tunnel through the heart of the Australian Alps. She launched with considerable fanfare on March 22, 2022. Nobody was prepared for what came next. Within weeks of that launch, something was wrong. Florence was meant to advance 30 to 50 meters a day. Instead, 60 centimeters, not 60 meters, 60 centimeters for an entire year. The long plain fault zone was far more unstable than any preliminary borehole survey had mapped. The machine was slowing to almost nothing, and the geological situation was about to get much worse. December 2022. Florence had advanced exactly 145.8 meters into her 15-kilometer drive. That's not a typo. 145 meters out of 15,000. The ground ahead wasn't rock. It was saturated, sandy fault material under enormous hydrostatic pressure, and it was flowing into the cutter head chamber faster than Florence could manage it. The earth vacuumed upward. A 15-meter wide, 4-meter deep sinkhole opened on the surface in Kosciuszko National Park, 175 meters from where Florence had entered the mountain. Florence couldn't move, forward or back. 2,000 tons, pinned. There's no tow truck for a 2,000-ton machine buried under a mountain. Can't winch it out, can't dig down from the surface and lift it. The saturated material had collapsed around Florence's hull. The friction alone, that soil gripping every centimeter of the outer shield, exceeded the machine's total hydraulic thrust. She couldn't push through it, couldn't reverse out of it. For 12 months, engineers worked on the problem, and eventually they came to a conclusion that sounds like something out of a science fiction film. They couldn't fight the mountain, they had to change it. If that's got you curious, like and subscribe now for more breakdown blueprints. What they did next is one of the most elegant engineering solutions I've come across. We're going in. This is where Eupalinos shows up again. Prepare the ground first, then cut. Engineers deployed something called the GIN method, the grouting intensity number. Developed in 1993 by geotechnical engineers Lombardi and Deere. The idea: drill injection holes around the machine and pump high-pressure liquid cement into the surrounding earth. Thousands of micro-injections, precisely controlled. The cement permeates every crack, every void, every saturated pore space. As it cures, the swamp becomes rock. Engineers were constructing a shell of artificial stone around Florence, inside a mountain. They called it invisible architecture, and that's exactly what it was. The physics had to be exactly right. Too little pressure, the cement doesn't reach the problem zones. Too much, you hydrojack the ground, violently crack open new fractures, make everything worse. The GIN method solves this with a constant mathematical product of pressure and volume injected. Two zones got different treatment. Perimeter zones, the liner interface, 500 pounds per square inch. Deeper mass consolidation zones, 870 pounds per square inch. One stable grout mix throughout. Water to cement ratio between 0.6 and 0.8. Tight enough to bond, stable enough not to segregate. Real-time monitoring from a Logak G5 recorder deep underground. Pressure, flow rate, volume, penetration. The invisible architecture was being built by data as much as cement. But there was something that should have been caught earlier. Florence was dispatched without fully commissioned closed-mode slurry capability into geology that was known to carry unstable, water-saturated fault zones. During the rescue period, engineers had to build a new slurry treatment plant on the surface, run a feed pipe underground, modify Florence herself. The slurry system works by pressurizing the cutter head chamber with viscous fluid matching the groundwater pressure outside. That balanced pressure stops the earth from flowing in. The modification took months on top of the grouting work, but by December 2023, Florence was ready. December 2023, 12 months after the sinkhole, Florence takes her first step. Slow, cautious, slurry mode fully engaged, but moving. The invisible architecture held. The engineers had changed the earth, and the earth obeyed. For a moment, it felt like the worst was over. By mid-2024, Florence had ground her way to 3 kilometers. 3 kilometers of slow, claustrophobic progress through the fault zone. Then the geology swung the other direction completely. Instead of saturated sandy ground, Florence drove into rock that was the opposite extreme. Hard, aggressively abrasive, high-strength granite. And at exactly this point in the tunnel, the alignment required Florence to navigate a curve. Abrasive rock plus a tight curve plus immense hydraulic thrust, the rock began to clamp onto Florence's outer shield. May 15th, 2024. Total halt. Again. Here's the problem with the hard rock jam. The jam method can't help against solid granite. You can't inject cement into dense rock. Compounding things. The worn cutter disc had degraded the bore to a slightly smaller diameter than designed. The 7-ton concrete lining segments no longer fit correctly. Under the operational pressure to recover lost time, Florence had been driven approximately 900 millimeters off her design trajectory before she seized entirely. The rock was physically impinging on the outer shield. It had to be removed. Without the cutter head, which was frozen, without damaging the hull. Millimeter by millimeter. Specialist contractors deployed ultra-high pressure water jetting, hydroblasting, supersonic streams of water precisely targeted at the pinch points around the shield, not cracking the granite, dissolving it, particle by particle. The same underlying principle as the ancient fire setter. You don't overpower the obstacle, you change its state, then you advance. 7 weeks of that process. July 11th, 2024. Florence could move again, freed twice. by changing the earth rather than fighting it. None of this happened in a clean engineering lab. Hundreds of workers were in that tunnel. After the chemical grouting rescue, toxic gas leaks were reported inside the tunnel network. July 2023. The chemical byproducts of the stabilization work accumulating in a poorly ventilated confined space. In early 2024, workers stopped underground operations entirely. The reason? Emergency refuge chambers. The fortified containers designed to keep workers alive during a tunnel collapse were allegedly not maintained to manufacturer specification. Evacuation drills hadn't been conducted in months. When the race to catch up on lost time starts compromising the emergency systems, someone has to stop the clock. The workers did. The money. When the Turnbull government announced Snowy 2.0 in 2017, the price was $2 billion. By the time construction was formally contracted in 2018, $5.1 billion. After Florence's first 12-month paralysis in 2023, Snowy Hydro reset the budget, $12 billion. New completion target, December 2028. But independent economists at the Victoria Energy Policy Center looked at the full ecosystem. The construction costs still to come, the transmission lines. The project generates power deep in the Alps and is useless without hundreds of kilometers of new cables to carry it to Sydney and Melbourne. The compounding interest over a 15-year build. Their figure, $42 billion. Every day of delay on Snowy 2.0 costs approximately $3 million in interest and holding costs. Florence's 12-month paralysis, an estimated $150 million in direct rescue costs alone. The indirect costs, measured in billions. There's a contracts lesson in all of this. Snowy 2.0 launched on a fixed-price EPC contract. Engineer, procure, and construct. The theory is clean. The contractor takes all the geological risk. If the ground fights back, that's their problem. Except when the losses become large enough to bankrupt the contractor, there's no one left to finish the tunnel. In 2023, the structure collapsed. A new incentivized target cost model replaced it. The geological risk came back to the taxpayer. Snowy Hydro's own CEO acknowledged, having your primary contractor losing billions of dollars isn't a great place for anybody. That might be the most understated sentence in the history of megaproject finance. When the mountain fights back hard enough, the public always ends up holding the cost. And so we arrive back at Eupalinos. One direction of attack isn't enough. In late 2024, the Australian government approved $75 million to procure a fourth TBM, named Monica, 178 meters long, 11.86 meters in diameter, shipped from Guangzhou, China. Monica's mission? Enter the head race tunnel from the opposite end, dig toward Florence. Two machines, opposite directions, both navigating the same hostile geology, meeting underground. Sound familiar? It's exactly what Eupalinos did on Samos in 530 BC, the oldest tunneling solution in the book. When one attack fails, open a second front. Here's what the Florence saga actually tells us, not just about tunneling, about the relationship between human ambition and geological reality. The mountain doesn't negotiate. It doesn't care about political announcements or contractual deadlines. The geology is what it is. And when the gap between the model and the reality becomes catastrophic underground, the options available to engineers haven't fundamentally changed in 2,500 years. Change the obstacle first, or, attack from two directions. The engineers who rescued Florence didn't invent anything new. They remembered something very old. That's the pattern. That's the echo. As of now, S&P has warned of a potential credit downgrade for snowy hydro. The $12 billion official budget is projected to be exhausted before the 2028 completion date. In 2024, the federal government injected $7.1 billion just to keep the project alive. Florence is moving again, slowly. Monica is approaching from the opposite direction. Two machines in the dark, boring toward each other through the same mountain. Same as Samos, different century. When they meet in the middle, Australia gets its battery. If they meet. If you want to follow what happens next with Snowy 2.0 and with the other engineering mega projects running the same geological gamble, subscribe now. And I want to hear from you. Drop a comment below. What engineering story do you want the blueprint on next? Because the next topic is going to be whatever you tell me it is. Either way, thanks for watching. The blueprint's always in the details.